Okay, so for this video, we're going to go over two kind of quick concepts. I'm going to go over what a single, double, and triple bond is and the properties of that, and then we're going to switch gears and go to a Lewis structure of single atoms. Right? So a single, double, or triple bond. So that would be represented by, let's say, a C bound to a C, right? That would be a single bond. Now, in a bond, we're going to learn this and we're going to, it's going to hammer it into our heads, but a bond is two electrons. So one bond equals two electrons that are shared. Right? So one bond is two electrons that are shared, and this is always going to be represented with a stick, if you will, right? Like just a line. So then you have the double bond, which would clearly look like this, right? And then we have the triple bond, which would clearly look like 1, 2, 3 with that. Carla, can you go over triple bonds? No, there's no more bonds than a triple bond. It's either single, double, or triple. There's no such thing as four. So this is sharing 2 electrons, this is sharing 4 electrons, and this is sharing 6 electrons. So let's talk about bond length. Now, if these have 1 pair between them versus this that has 3 pairs between them, what effect does that have on bond length? Well, if you're sharing 3 pairs of electrons, that's going to be a really tight, right? That's going to be a really tight bond between them. So this is actually the shortest, right? So this is the shortest in length, whereas this is the longest. And Mr. Double Bond, he falls somewhere in the middle. Then we're going to talk about how hard it is to break these, right? Do you think it'd be easier to break 3 bonds or 1 bond, right? So it'd be easier to break this. So this has the highest bond energy. This has the lowest. Right? So that's the trend there. Yep. Terrible handwriting. There we go. Highest bond energy, lowest bond energy, and this is the baby bear who has somewhere in the middle. Porridge isn't too hot or too cold. So let's switch gears and talk about Lewis structures of single atoms. So this chapter we're going to really get into Lewis structures, and Lewis structures deal only with valence. So that's a big thing to get straight right now. Deal only with valence electrons. So they don't deal with anything else. So we're going to have to, so let's say that we want to draw the Lewis structure of magnesium. We want to draw the Lewis structure of nitrogen. And we want to draw the Lewis structure of cobalt. Sure, why not? Excuse me. So magnesium, what are the valence electrons on magnesium? So magnesium is in the 3rd energy level, and it only has 2 electrons in that 3rd energy level, right? So remember, you just count the columns 1, 2, 3, 4, 5, 6, 7, 8, right? So magnesium only has 2. So you could draw it like this. Or I've seen it represented like this. Either way is appropriate. For nitrogen, nitrogen is over here, and nitrogen's in the 5th column. Right? We should be able to do that pretty quickly after some practice. 1, 2, 3, 4, 5. So nitrogen's going to have 5. So 1, 2, 3, 4, 5. Right. Cobalt's a little tricky though, right? Cobalt is a transition metal, so he's right here. So how many valence electrons does he have? He only has 1, 2, right? Because this is the 4s1, 4s2, and then these are all in the 3d. So these do not count as valence, do they? So he only has 2. So cobalt would be represented like that or like that. Those are, either way is appropriate. Okay, thank you.